So as I said, 5.4 is a very, very easy section. It's quite quick. Okay, so the first theorem we've actually already talked about. It's called the triangle inequality theorem. So the way that I presented this to you before is I said, you know, if a side length is, I don't know, side 10, and I have another length that's maybe like 2 inches, and then a third length. Okay, imagine this 2 is on like a hinge. And I can rotate it around, and so it could be like totally flat up against this. Does that make sense? That means in order to get a triangle, I would need this other side length to be greater than 8. Do you guys remember that? So if it's 8 exactly, then that's too short, because we would have basically 2 along here, and then we'd have 8 here, and it wouldn't make a triangle because it wouldn't bump up to create a triangle. Do you guys understand what I mean by that? So our theorem says that if we have 2 sides of a triangle, so let's say the 2 sides are A and B. So if I have A and B, then that has to be greater than the length of the third side. So A plus B must be greater than the third side, which is C. Okay, so like I said, if I had a length of 10 and 2, then my third side needs to be bigger than 8. But there's kind of a limit on it. Okay, so it could be bigger than 8, it could be like 10, it could be 11, but then what about 12? So then that means our longest side is now 12, right? And if our longest side is 12 and I have 2 and I have 10, then again, it's back to that situation. So the third side must be bigger than 8, but it has to be smaller than what? Smaller than 12. Do you guys see it? Because if 12 was the biggest, then those other 2 sides won't bump up to make a triangle. It has to be smaller than 12. It could be like 11.9. That would be enough. So it must be, third side must be bigger than 8 and smaller than 12. Okay, so it says, can a triangle have sides with the given lengths? So I always kind of put the longest side on the bottom, and then I think, you know, if this was 2 and this was 3, would that be enough to create a triangle? Does it work? No. Why? Because they're not going to reach each other, right? They're not, the way I drew it, you can definitely see, but I could have drawn it like this, and you guys would be like, oh yeah, it works, right? So, I mean, if you took a ruler and you did 1, 2, 3, 4, 5, 6. So see these 1, 2, 3, 4, 5, 6 markings, and then I had one that was 2 and one that was 3. You would see that they couldn't bump up and match, right? Think of them on hinges. We sometimes call this the hinge theorem. Do you guys see that? It's not going to make a triangle, so no. So could you have 15, 15, and 1? Yeah, that works. So you could have like a 15, and then a 1. That would work. 8, 10, and 19. Think about the biggest one on the bottom. 8 and 10, is that enough? No. 8 plus 10 needs to be bigger than 19, right? So this is no. And same idea on this one. So 15, 11, and 12. Does that work?
Yes.
Yeah, that's fine.
So does it matter what like the number order is? So can we assume then that 19 would be the biggest side?
Well, 19 is 19. It is the longest one, right? 19.
Okay.
Yeah. All right, so it says, what if we had 2 sides? So if I have 8 and 12. If I have 8 and 12, we want to know the range of answers we could have for the possible third side. So I'm going to say x is going to be the length of the third side. X has to be at least what? So it has to be between what 2 numbers? What's the smallest it could possibly be? Kind of. No. 4, right? So you subtract them. Okay, but it can't be exactly 4. If it was exactly 4, that would be bad because we have like a 4 and an 8, which aren't going to pop up to create enough to create a triangle, right? It has to be like 4.1 or 4.01, just enough so that's a little bit bigger. And then what's the biggest that it could be without being equal to it? 20. Does that make sense? So our third side has to be between 4 and then 20. So if you think about it, so if 12 was the biggest, right? That's what I'm saying. I can't have a 4 and an 8 and create a triangle with that. They would be flat against that 12. Do you guys understand what I'm saying there? But if this was like 4.1, then it bumps it up just enough so that it creates a little tiny, like a very flat triangle, but a triangle. Does that make sense? So it has to be bigger than 4. All right, so 5 and 16. What do we think? What two numbers am I between? 11 and 21. What are we doing to get these numbers? This is a very easy process. We're subtracting the two numbers, 16 minus 5, and then we're adding the two numbers, 5 plus 16, right? So what do I get on this one? Subtract the two numbers. Nobody wants to do 23 minus 18 without a calculator, right? Not that hard, you got it. 5 and 41, good. All right, third side on this one. You can use a calculator if you want to. I don't think you need to. So 7.8 minus 5.2. 2.6, exactly. So we have 2.6 is less than x, which is less than 13, exactly. Does this make sense? Easy enough? Can you guys remember that formula? Totally. All right, so then the other theorem is also very, very easy. So if I draw out a triangle, I think you guys will totally understand this. Let me draw this one a little bit longer. Okay, so if you compare these angles, these three angles are different. Oops. Okay, and I have a small angle, a medium angle, and a large angle. And you could draw, you know, other ones. I don't know. So I have a small, medium, and a large. This one kind of looks the same, but. So you could try to compare these. Okay, across from the smallest angle is the smallest side. So this is the smallest angle. It is the most acute, right? The smallest angle. This is the smallest side. Okay? Across from the medium angle. So this is the medium angle. Oh, no, wait, that's the long angle. What am I talking about? Medium angle. Where's the medium angle? Medium angle, medium side, right? Large angle, large side. Does that make sense? Okay, so let's think about why this is. So the more acute, the more tiny an angle becomes. So imagine again that this is on like a little hinge here, this angle here. And let's say I open it up and it gets bigger and bigger and bigger and bigger and bigger. Do you guys see how the side across from it gets larger as you do that? Yeah, does that make sense? So the more you open an angle, the bigger the side is across from it. Okay, so in this problem, it says list the angles of each triangle in order from smallest to largest. So we have a small, a medium, and a large side. So across from the large side is the largest angle. Across from the medium side is the medium angle. And across from the small side is the small angle. Okay, so if I want to list it from smallest to largest, my smallest angle is what? Angle K, L, or M? M. Do you guys see it? So this is my small side, so across from it is my small angle. All right, and then what's the next one? So across from the medium side is my medium angle. Angle, nope, L, And then across from the large side is my large angle. So angle K is the last one. That looks like an L. Okay, so same idea on this one. But I don't have all the sides listed. I could find that third side by Pythagorean theorem. But is 90 degrees, isn't that the largest angle? Can we assume that? Yeah, 90 degrees has to be the largest angle. You can't have two things that are more than 90 degrees. All right, so that means my smallest angle is angle G, my medium angle is angle H, and my largest angle is angle I. All right, you guys are totally spacing out. I know this is easy, but just pay attention. It's not that hard. All right, so this next one. So now we have x and we have 3x. So that's helpful to us in this case, right? So I know my large side is across from the angle E. Why do I know that has to be the largest side? Yeah, it has to be the largest angle, right? We can't have two things that are 105, right? That's definitely the largest angle. Okay, and then when comparing my x and my 3x, which one has to be bigger? The 3x, right? Because it's 3 times longer, right? So this is the medium, and this is the small. So if I go across from the small side, I get my small angle. So I'm going to have angle D. Across from the medium side is my medium angle, angle C. And across from the large side is my large angle, angle E. So small, medium, large. Making sense? Really not that bad, right? All right, and then same thing with this one. So cross out C on your example, because I think I messed C up. So we're just going to do A and B. So if I have 45 and I have 75, I can find that third side, right? So 45 plus 75 makes 120. So what's the missing angle? What's M? 60, right? So fill in 60. So we have our angles. So we have, like, the angles would be smallest is O, medium is M, largest is N. So now we want to do the sides in order from largest to smallest, or smallest to largest. So the smallest side is across from the smallest angle. So we're going to have MN. And I'm going to put a little segment over it. So that side length, that object. Okay, and then across from the medium, so the medium is 60, so across from it is this side, ON. And then the large across from it is OM. So MN, ON, OM. And you could mix those up, like you could say NM instead of MN, right? All right, and then this one says triangle XYZ, so let's draw it out. So I have X, Y, and Z, and I know X is 51, Y is 59, Z is 70. So if I was trying to do this without a picture, look at the side across from X. What's it named? YZ. So it uses the letters that didn't include X. Does that make sense why that would happen? Okay, so we would have YZ, and then we would have across from the medium. Well, the medium's Y, so XZ doesn't include Y, right? And then across from the Z, XY. So that's small, medium, large. Make sense? So you don't have to draw the picture if you don't want to, but picture always helps. Okay, easiest section ever, like I said. All right, so let's stop there.